Hey everybody, welcome to the Green Cover Podcast, where we have really interesting conversations with some of the top regenerative farmers and experts to discuss how we can help people regenerate God's creation for future generations. Have you ever described a simple subject or a topic as, well, it's not rocket science? Yeah, me too. But what if I were to tell you that what is going on in the soil right below our feet is way more complicated and fascinating than rocket science? Well, I'm not actually going to tell you that, but our guest today, Dr. Laura Kavanaugh, who is both a rocket scientist and a bioinformatics software engineer, is going to explain why the soil is way more fascinating than rockets.
I'm here with our friend Laura Kavanaugh. Laura, we've known each other for a number of years. You are now the Chief Science Officer with AEA, Advancing Eco-Agriculture. So very excited to have this conversation with you here today. And we're actually here in North Carolina at Union Grove Farm where we first met.
Yes.
And so let's give our audience just a little bit of background into maybe a little bit of how we met, but also how the progression that you have come to become the Chief Science Officer with AEA.
Yes, it's quite a wandering story, Keith, like most people's lives or many people's lives. I'll just take a quick step back, but I won't take too long, don't worry. But I started out in engineering and had my education in engineering. The last thing I thought about was farming, really, and actually had a career in the space program and the space shuttle program at the Johnson Space Center. But after that program was winding down, I decided to go back to school and get my PhD in genetics and genomics at Duke. And after that, I ended up taking a position with Syngenta to study genetics in plants and do a lot of work on GMO and so on. And that was a really exciting career, and I loved that, except over time, I came to decide that the GMO approaches we were using, they just weren't long-term solutions. Nature's always working to overcome any single silver bullet, and it always does. And so I just thought, I don't want to spend my life working on something that I know is only temporary. And so I started really thinking, what would be a long-term solution? How do we really grow plants sustainably? And the more I studied that question, the more I came to realize that the soil microbes, the plant-soil microbe interaction is really the long-term powerful solution. Yeah. Obviously, it's been here for millions and millions of years, and it survived all of these environmental fluctuations. So that's really where the solution lies. And then as COVID was coming up, I ended up getting laid off from Syngenta, and actually through a series of unusual coincidences, I met an amazing person named Martin Crompton, who is the head here at Union Grove, and he and I got connected, and then I came here as a soil health expert to work at this vineyard that was just getting started and really focusing on regenerative farming. And through that, I ended up coming to a number of conferences on regenerative farming, and that's where I met you at the Regen Nexus conference. And Martin, being the amazing connector, he actually gave me a chance to speak at the conference. And I was talking about the DNA sequencing that I was doing of the soil here and how I wanted to bring that to regenerative farming. Mm-hmm. And then another amazing coincidence was that John Kemp was in the audience. And when he heard me talking, that struck up a conversation with us. And then our conversation, we got super excited when we were talking together because we had so many common excitement about the soil microbes. And so then one thing led to another. So now I'm the Chief Science Officer at AEA. So
and I think it's a great testament to those Nexus conferences, because the word Nexus, it's a coming together, it's a place where people connect, and that's what it's all about. And this is like the ultimate example. Now we can't guarantee that everybody will get a really great dream job being there.
Right.
But that's just a great example of the type of connections and the type of people that come to these events and the connections that are made. So
it is. It's a really powerful event because it just brings people of the same mindset together, that network. It's you don't have ideas, but when you're with people with similar thoughts and thinking, it's just like the ideas are really come
really
together.
stirs up that
connection.
creativity. And
Yes.
Martin's a great one for bringing people together.
Yes.
So
Martin's an amazing connector.
lots and lots of fun. I love to tell the story when the first time we came here, like 4 years ago to Union Grove, Martin was so excited that we were coming and I was going to be able to tour around and everything. And on our way here, he had to call me and say, "Hey, Keith, I've got COVID. I can't even
I can't even come." Right.
So he was pretty bummed out. So, but I'm back and we're touring around and just having a great time here in North Carolina.
I got to have all the fun meeting you.
That's right.
That's right. Martin, poor guy.
Yes. So anyway, with all that great background, you're probably the one person in the world that can say soil health, it's not rocket science.
Because way harder than
because you know both.
Science.
So
it's actually much harder than
more biology is always going to be much more complicated than physics or chemistry or anything. But it's exciting.
Oh yeah,
it's exciting.
I know. It's funny. I have a friend who, when they heard that I was going to be studying soil and farming, and they're like, you used to work on the space shuttle program and now you kind of you work on dirt. Is that kind of disappointing? And I was like, no. This is the most unbelievably exciting, complex universe under the soil. It is not disappointing at all. It's as complicated as space.
Yeah. And I think that's a fascinating perspective. And so your specialty within this soil health realm, because we each kind of have our own little, niche that we carve out and we're really good at. Yours is DNA and DNA sequencing. So you're really looking at the building blocks of how all of this is working. Talk just a little bit about how you got started down that path and where it's led you to the lab that you've set up with AEA and where that's going.
Right. It's just really this deep discovery that nature's really set up in an unbelievably robust, complex system already. And that we don't really need to come in and create it. It's a difference in our mindset. Humans, we think we need to create something. We want to build a house. We have to bring everything and build the house. In the world of farming, it's actually everything's already there. And this DNA sequencing I can use to go in and reveal that universe that's hidden. And particularly in the last 50 years or since World War II and the fertilizers became very popular, they seem to have a very awesome effect initially, but over time they kill the soil life, and then we lose all the benefits of that life, which is the soil aggregation, water holding capacity, just keeping the soil together. All of those things start to go away, and then we have to bring in more and more and more. So it's important that we show farmers just conceptually, we've lost the idea in the last 50 years that it's really the life in the soil and that interaction with the plants. We have to have that dance between the plants feeding the microbes feeding the plants to really get solid farming that's going to last for hundreds and hundreds of years. And the DNA sequencing and some of the latest technologies are so powerful and the costs are coming down. And it's this convergence of all these technologies, all the computer capacities we have now and AI, like all the pieces we need to really start to unravel this are all converging right now. And so it's a super exciting time. And we want to bring that through advancing eco-agriculture. What's really awesome with working with someone like John Kemp is he has all the agronomic knowledge. Yeah. And then we've had folks doing sequencing of soils, but it's connecting that with the agronomic knowledge. So when John and I get together and we're able to bring both of those strengths together, I think that can really move farming, help reveal what we need to do, and they'll help guide things. And then the work that Green Cover's doing, looking at the seeds and growing them in regenerative environments where the seed already comes with a really beautiful, fabulous, powerful microbiome in it. So you have to have that seed that starts with a powerful microbiome, and you have to have a soil that can sustain that microbiome and let it grow. You can't just take microbes and chuck them on a dead field and grow. They have to, you couldn't put a bear in the middle of a desert.
They have to have a habitat.
They have to have a habitat.
Yeah.
So you optimize the starting point with the seed, then you optimize that habitat by maintaining seed and living roots in the soil as much as you can. And that's the way.
And I want to dive into that just a little bit, but before I do that, so yesterday I was speaking at the North Carolina Soil Health Coalition, one of their workshops, and I'm doing another one tomorrow. But one of the speakers there at this conference, he said a quote. I've just been thinking about it, and I can't even remember who he quoted, but this was I think he'd heard his grandpa say it or something. But the quote was, "In nature, when you kill something, you inherit its job." And so when we're killing all these microbes and we're killing the biology because of the way that we've farmed, or even the weeds, we just now have inherited the jobs that they were there to do.
That's an awesome quote.
And that's what we've been doing in agriculture, because as we, not intentionally, some things like the weeds we intentionally kill, but the microbial population has been, an unintended consequence of the way we farm. But we've now inherited the job that they were put there, they were created to do.
Right.
And that comes at great expense. It comes, we can grow really big crops, but there's no profit left because we're paying so much to do the job.
And we can only do 1,000th of what they're doing.
Yeah.
We can't get the soil to hold water.
Yeah.
So now we're just in these super brittle situations where I plant the seed, I have to get this rain right now and at the right times, or the whole crop's
We've lost the resilience.
We've lost complete resilience.
Yeah. So anyway, I just think that quote was just fascinating to think about.
That. It's true.
But as we bring them back, now we have fewer jobs to do.
Exactly.
And that's the whole point of regenerative agriculture, is having fewer jobs to do, because we have the biology doing the jobs they were created to do. And your technology, your science, the lab that you set up is giving us a little peek behind the curtain of some of that's going on.
It does. And I just get so excited, Keith, because I get this data sometimes and I just can't even believe how many microbes are there.
Yeah.
And
so can you give us an example of like a soil sample that you do a DNA test on? What kind of numbers are we talking about?
I'll see 10,000 species. 10,000
in a single soil sample.
In a single soil sample. Like the size of your tip of your pinky.
Not 10,000 organisms, 10,000 species.
There's trillions of organisms. I don't measure trillions. I'm sure that what I'm able to see with this technology, even though it's our most advanced technology, is still only a tiny portion of what's there.
You're just estimating.
Even with that, I like what you said, you're just pulling back the curtain. I could see 10,000 things, and I could see worms, I could see microarthropods, I could see bacteria, I could see fungal species. There's like the whole breadth. There's just, it blows my mind. It's wonderful.
Is that 10,000 that you can identify? And then are there other things that are kind of
that's a good
still
point.
black data that you don't even know what it is yet?
Absolutely. Right now we think we might have been able to classify. I don't know how you classified the percentage of something you don't know, but they estimate like 1 to 5% of what's in the soil we actually can identify. Now what we do is we identify, I can't identify the exact species, but I can identify that it's in a family or something, because the DNA is common across those kind of things. So we classify a lot of things, but at a very high level. So instead of saying that's a black bear, I might say it's a bear or it's a mammal. You can go up the tree.
Yeah.
But yes, we know so little about.
So 10,000 that you know of, but there's likely many, many more.
Oh yeah.
And we'll continue to learn about that. Right. You'll develop the libraries to identify those down the road. That's
another thing I'm excited about, is with this data, we can actually start to do genome assembly, it's called. So you see all that DNA and you could start to, even though all those genomes are mixed together, you could still piece things together. So the more we sequence, the more we'll be able to reveal what's there, and the more we'll understand the patterns.
And so you're doing that with soil samples, but you're also going to be able to do this with seed as well, right? That's
one thing I'm in particularly looking at right now, because I think the seed is key to starting a good regenerative plant. You have, just like with a child, it's always best when their early development is critical.
Yeah.
And so the same, no doubt, is for seeds. So looking at the seeds and seeing, are we getting rich microbiome encoded inside the seed from the parent? can be super important.
Yeah.
Because that's, that leads into nutrient density. The more a plant can get nutrients from the soil, it's using that barter system with the microbes to get those nutrients. That means the humans, us, get more nutrients. So it's not just like this theoretical, interesting question. It's
And
very
we can do that with fewer
question.
inputs, less expense, more profitable.
Exactly. We need to lean on nature. Nature's figured this out because you don't survive. If you don't figure it out, you don't live in nature. You're gone.
Yeah.
So the fact that it's still here, it's figured out.
Now, this summer when Christine Jones, or this past summer when she was here, she made the comment that a single seed can have up to 9 billion microbes, in it and on it. And that number just stunned us. And I've heard other people say that since. And so again, your technology will allow us to kind of start getting a peek at that and really start to be able to ascertain how microbially healthy is our seed. Well, I can send it into a lab and get a germ test, but that doesn't tell me anything about the onboard biology.
Right. Well, and I think we're even though we're very early in our knowledge of what's really happening, because DNA sequencing technology, I think the very first one, they won the Nobel Prize, was in like the 70s. Like, this is just brand new in human knowledge. But it's showing us that there's so much more there than we ever thought. And we don't need to know the 11,000 exact species. We just need to know there's a lot of species there. And what's fascinating is I've gone in and I've looked at like regenerative farms. Go look at Rick Clark's farm and pull out some soil. And then 100 feet away, go to a neighbor's farm, and it's like night and day. There's almost no living organisms in that neighbor's soil. It's not the environment. It's not the macro environment.
Yeah,
it's not
the soil type.
Not the soil type. It's our management of those systems. And you don't have to know a bazillion things about microbes and every single one that's there and every single thing they're doing. But when you walk in a healthy ecosystem in a forest and there's all these animals and living things and plants, you're in a healthy ecosystem. And you go over here and there's nothing. You don't need that much information. You just need to know that environment's not healthy and this one is.
Yeah. So this data is going to be really cool. See, we've got 10,000 species. We've got X number of species of microbes in or on my seed. But a lot of the people who I think will be listening to this podcast are going to say, okay, great, but how is this practical for me as a farmer? What kind of actionable, recommendations can you make for me from this?
Right.
Will your test also be saying, here's what you should do to improve it, or here's what you can do to get to the next step? How will farmers be able to use this to really improve what they're doing?
Right. So we have a number of things we know how to improve the soil, the health of the soil. And so I think this kind of gives us, as a starting point, you kind of have an A, B, C, D, or F score. And if you don't have a very good score, we know we need to start growing covers. We need to keep living root in the soil. We need to reduce our tillage. We need to stop compressing the soil. There's a number of things we can advise. This is how you take from here to get here. And even if you're in an A situation, we're talking earlier about, can we tune our covers to optimize our cash crops? Can we tune the way we're doing tillage? Like, it's probably okay to do some tillage. How often can you do it? How deep can you do it?
It's a tool to be used.
How do you know what the right thing is? You can try a number of those things and then see how the soil recovers by measuring the microbial life directly. Then. Right. Yeah. So I think this will help us really tune these things a lot faster and know, especially, we don't know a lot of times treatments. We put things on. Was that herbicide or this pesticide or these? I have gazillions of options and they all make all kinds of claims. But what if I use that, and how does that actually impact the soil? What does the soil tell us? What does the plant seed tell us? Are we getting the transmission in the seed, or are we doing something while we're handling that seed that we're
Yeah.
destroying that?
So are you looking at this as a way that people can do a before and an after, get a baseline, apply a treatment, and then test again and just see how that affected
I think you could
the
do
whole
that
microbial community?
just looking at your soil over a season and how it's doing over a season. I'm super interested in looking more deeply at what's right at the roots of the plant and the micro root interface, that rhizosphere. Because that's really where the rubber meets the road. Let's say you put in a great seed, but you have not a very good environment, and pretty much the microbes can't survive once they're in there. How would you know that? You go in there during the season and you pull some plants up and you look at that rhizosphere. Have I succeeded in getting the plant communicating with the microbes? And are they in this beautiful dance of exchange? So there's, measuring, am I actually getting the outcomes? And seeing that, because we can kind of watch from the outside, but we don't know. And then can we correlate that with nutrient density and some other things? Are we really getting that plant to uptake these nutrients we're applying, or how is all that working,
Well, and
That's the
I mean, this is opening up a whole Pandora's box of
Right.
things we could follow up on,
Right.
the correlation between these microbial communities and nutrient density. And so, it's really exciting to know that this is still in its infancy stages, but it's going to lead to lots of really cool things
Right.
down the road.
As we learn to leverage the value of nature and the power of nature, we don't know how to do that. So we can use this to kind of help guide us trying these different things. How is nature actually enhanced the most, and which treatments? We're going to find surprises.
Yeah.
It's
Well, and I'm super excited about this because we've always thought that, a lot of our seeds are grown by some of our best customers, some of our best regenerative farmers that we work with. They're growing some of the seed that we sell. Rick Clark, for example, is growing some of our buckwheat. We've just got great farmers growing these things. So we've always thought that our seeds are better because of who and how they've been grown. But now we'll be able to put some quantification to that.
Exactly.
Yeah. And so that's very exciting for us to know that that's now a possibility, that we can start now saying, yes, this seed was regeneratively grown and it's better. And here's the proof. Here's why.
Right. Because most farmers, seed is seed is seed. It all looks the same.
Yeah.
But now you can actually measure, and that's super important because that's going to be from the beginning if they're interacting with microbes.
Yeah. So we're really excited about being able to work with you, getting some of our seeds tested and stuff. And so I know that a question that a number of people will have is, okay, well, great. This sounds super good. I'd love to be a part of it, but is this going to cost $300, $400, $500 a sample? Can I really afford to do that? And I know, again, you're just in the early stages of this, but can you give just a little indication of what you think the testing will cost?
Yeah, I think it's very important. It has to be accessible in a cost point, or else no point to it, because nobody's going to be able to do it. And especially if you want to do it over the course of a growing season, you'll need to be a price point. We're trying to shoot for something like 150. I want to get it down to 100. We talked about a number of things that contribute to cost that really have nothing to do with the technology around, shipping and things. So we want to get that down, but we want to make this really accessible. And I also have, as I mentioned before, this big dream to not just be for farmers anymore. I want it to be for people who have a garden. I want them to understand. I just don't think people understand that who would? They're invisible, that these microbes are so important. I want a homeowner. I want someone who grows their own garden to be able to measure their soil.
Yeah. And you're talking about helping people develop a regenerative mindset.
Yes, exactly. To really get that there's really living things in there. And when like I said, I get my data and I see 10,000. I mean, sometimes I just sit at my computer and my jaw just dropped, and it's like, is this even possible?
Yeah.
It's so amazing, and it's
peek
mind
behind the
blowing.
curtain. Yeah. And I want to go back to that cost thing, because I want to make sure people understand that part of that package is you're shipping them a box cold packs, because we're talking about living DNA, so you can't just throw it in a box and let it set on the dash of your pickup for 2 days. And
Right.
this has to be frozen. It has to be sent in,
Right.
with priority shipping so that it stays frozen and cold. And so that's all part of that fee, is that
Right.
you're providing the packaging, the cold packs,
Right.
all of that
Right.
is part of it, and the return shipping. So, we're going to be paying for some convenience, but it's also
Right.
making sure it gets done right.
Right. It's important that you don't get your sample and then it changes a lot.
Yeah. So that's
And
all
that
part of it.
shipment's part of
And
that.
because of that, then the more samples that someone would send in at the same time, the more cost effective it
Right.
would be, because we're not having to pay that shipping on every sample.
Right. Right. You
Yeah,
can send
so
4
there's-
at a time. And that's what's kind of cool, because you could take a sample this month and stick it in your freezer. And
Yeah.
then you could take a sample next month and stick it in your freezer.
Mhm.
And you could send it all at the same time. So you don't have to collect the
So if
samples
I'm doing
at
a
the same
before
time.
and an after, as long as I'm willing to wait, I can collect my before, stick it in the freezer, do my treatment, pull my after sample, and send them both in at the same time.
Yes. So there's ways to try
Yeah.
to keep the cost down.
Yeah.
That's super important. John and I have talked about that. It's no value if people
Right.
don't have access to it.
Right. Yeah. And so
And so that's
we'll continue to see that come down. And that's one thing I've always appreciated, working with, John and AEA. We feel like they have a very similar mindset to Green Cover, in that, we're thinking like farmers. We both come from farming backgrounds.
Right.
We're thinking like farmers, and it's like, wow, that's too expensive.
How
How can we cut that cost, or how can we make that better?
Well, that's why I was so excited to get connected with John,
Mm-hmm.
because I've known about this technology, and I worked in an agronomical company,
Yeah.
Syngenta, but I didn't have my hands in the dirt, and I didn't, when I get this information, how do we translate
Yeah.
that into a very practical?
Yeah.
And so that's why working with John is
Well,
so
I remember
exciting.
that first conference you came to. You were like, "Yeah, I have a DNA sequencer in my
I know.
purse." It's like, who is this lady?
I know. I brought that out at the table, and everyone's like, "What is she talking
Yeah.
about?" Yeah.
But this is just the logical extension of that technology that you've developed, which is just super cool to be able to bring that in an affordable manner to farmers.
Yeah.
And again, to help us make practical, informed decisions to grow
Right.
not only healthier food, but also doing it in a more profitable manner.
Right.
And I think that's the goal of both AEA and Green Cover, is to help farmers facilitate that.
Yeah. And it's rare that there's been such a win-win kind of proposition. I mean, regenerative farming is financially a good thing for farmers, but it's good for human health.
Yeah.
It's good for the environment. We need to stop putting these chemicals out in the environment. Nobody's a bad guy here, but the more chemicals we put out, the more fertilizer, the more damaging we are to the whole environment. It's a win-win for everyone.
And when you kill those things, you inherit their job. So
Or you inherit
then
their
it makes,
problem.
then it makes
Yeah.
our job not only harder, but more expensive. Well, this has been a great conversation. Here's my suggestion. I'm going to say that Green Cover will send in some samples of some seed. We'll send in some samples of some soil. I think it'd be really interesting. We can have a follow-up podcast episode where we can talk about some of those results.
That'd be wonderful.
We can make the analysis available to people. Then we can kind of discuss it. People can look at it. We'll pay the expense of doing that, but then people can get a little peek into what some of the
What
results
it's all
would be.
about, and
So,
what kind of recommendations. come
yeah, I
out
think
of
that would be a really fun thing.
Yeah,
a fun
I
follow-up
would love to
episode
do
to
that,
do.
Keith.
So,
That'd be wonderful.
well, any closing comments, Laura?
No, I'm just so excited about the regenerative movement. I have kids, and I want them to live in a world where they can be healthy and the environment's healthy. And it's been rare that we've had a chance to really impact, not just the United States, the whole world.
Yeah.
And I'm glad there's a lot of leaders in other countries. In the United States, farmers have been kind of locked down, and some mindset and some incentivizing that kind of keeps them locked in. But there's other parts of the world that can still act and move regenerative farming forward. So,
And this community is such a sharing community. That's what we see at the Nexus events all the time, is people are just so willing, open to share and very few secrets, very few
Right.
secrets.
And that's the beauty of it. I can do my own system and I can give you all the information. It doesn't take away from me.
Yeah.
It's more like lighting a candle. You just light
Right.
it. You don't give away any
It's a
secret
great word
sauce.
picture
It's-
for it
yeah.
now. Yeah.
So yeah, thanks, Keith. I
Well,
love
yeah.
this
Thanks
conversation.
for sparking this candle, and we'll all light ours off from that. So
Sounds great.
thank you so much.
My brother and I started Green Cover in 2009 because we understand what it's like to be a farmer starting out on the journey to improve soil health. We saw the power of plant and biological diversity on our own farm here in Nebraska, but we found that it was difficult to get the right cover crop seed mix. We also learned that there was a big learning curve in successfully implementing cover crops. That's why we built Green Cover, so that farmers like you can access the highest quality cover crop seed put into the right diverse mixes, along with the technical advice and the educational resources to help you successfully implement cover crops on your own operation. So contact us today and we'll help you with the right cover crop mix for your farm or ranch so you can regenerate your portion of God's creation for future generations.